Today we are going to look at what is called identity equations. Identity equations are equations where both sides of the equation reflect each other. So, if you look at the equation 27 equals 27, that is an identity equation. The left and the right side equal each other. Now, if we look at another identity equation, 15 plus 12 equals 15 plus 12. You will see then that the left side is 27 and the right side is 27. That is an identity equation. But sometimes with identity equations, you have to simplify both sides of the equation to see that the left side reflects the right side. For example, you might have the same equation, 15 plus 2 times 6 equals 15 plus 2 times 6. 2 times 6 is 12. 15 plus 12 is 27. And I'm going to solve the the right hand side. 2 times 6 is 12 plus 15 equals 27. Same answer, different numbers and different operations in the orange equation, but you still get an identity equation. Now, we're going to use the same answer and come up with an equation with a variable. 15 plus 6x equals 15 plus 6x. Now, if I were to come up with any number to plug in for x, I will see that both the left and the right side will still equal each other. So I'm going to set x to equal 2. X equals 2. I'm going to plug in 2 for x to get 15 plus 6 times 2. I get 12 plus 15. That's 27. I do the same thing over here. On the right hand side, I'm going to plug in x for 2. To get 12 here. 15 plus 2 is 27. 27 equals 27. This is an identity equation. Any number that you choose to replace x or to substitute in for x, you will always get the same answer on the left-hand side as you do the right-hand side. So let's try using 3 as the variable. Let's do x equals 3. 15 plus 6 times 3 and 15 plus 6 times 3. I'm going to multiply first, follow my rules of order of operations, and I get 33. You can see that this is still an identity equation. The left side equals the right side. We do come up with two different answers if you use a different variable, but it's still an identity equation. Sometimes with identity equations, it's hard to see that both sides, the left and right side, equal each other. So we have to simplify the equation to see that they do indeed equal each other. So for example, if I have 5 plus 2x times 5 plus 2x equals 15 plus 6x. We know from last week that we have to use the distributive property to distribute the 3 to get 15 plus 6x equals 15 plus 6x. You can stop here to see that this is an identity equation. The left side equals the right side. Now let's try a different equation that is a little bit tougher to see that it is an identity equation. 15 plus 6x equals 1/2 times 32 plus 12x minus 1. Now, this is an identity equation in disguise. We have to simplify both sides to see that it is an identity equation. And to do that, we have to first distribute the 1/2 times everything in the parentheses. 1/2 times 32 is 16 plus 1/2 times 12x is 6x minus 1 equals 15 plus 6x. Now I can simplify this even further by combining like terms. 16 minus 1 is 15 plus 6x equals 15 plus 6x. This is still an identity equation, just an identity equation in disguise. So this brings us to our definition of an identity equation, which is an equation that is true for every value that is put in for the variable. Also known as infinite solutions. And that's it.